Good morning, students. We have learned in the last lecture, if we pass a current through a straight wire, magnetic field produced around it, which is in the form of concentric circles, which have the center at this point at the wire. Now, by using the right hand thumb rule, we can also find the direction of magnetic field produced around this straight wire. If we want to increase the strength of this magnetic field produced by this wire, we can increase the strength by making this wire in the form of coil. If we make a coil of this wire, we found that the magnetic field produced by it increases. Make this wire in the form of a coil in a loop and connect it with the battery and with a key, or we can say a switch. And if we switch on, the current will passes through this loop. The current start to pass through this loop. Now every section of this wire behave like a magnet. We only आप शो कर दो, जैसे आपने यहाँ पे शो किया था, यू शो द मैग्नेटिक फील्ड लाइंस प्रोड्यूस्ड अराउंड इट. इट डोंट मीन कि और कहीं पे नहीं हो रहा है. इट हैज़ मैग्नेटिक फील्ड अराउंड इट थ्रू आउट द वायर. सो if we make it in a circular loop, in the form of a circular loop, the magnetic field will be produced at every section of this wire. Now suppose at these two points we want to find the magnetic field produced by it. We can use the right hand thumb rule. By using this right hand thumb rule, we know that the direction of current is in this direction. So the magnetic field produced around it is in the form of these concentric circles, which has the direction like this. And what is about this? The direction of current is in this direction. By using the right hand thumb rule, we can find the direction of magnetic field produced around it like this. So direction of magnetic field produced around it is in this direction. And what is about in the center of the coil? The concentric circles are produced by this part of the wire and also by this part of the wire, and as we move away from this center or this wire, we find that the circles become larger and larger. And at the center of the wire, we find that the magnetic field produced around it is a straight line, because the magnetic field produced by this wire is like this and by this form is like this. And अब दोनों जो है मैग्नेटिक फील्ड प्रोड्यूस करें तो क्या होगा, दोनों का जो मैग्नेटिक फील्ड है इट विल एड्स अप, एंड एट द सेंटर वी फाइंड द मैग्नेटिक फील्ड प्रोड्यूस्ड अराउंड इट हैज़ द हायर स्ट्रेंथ. यहाँ से भी प्रोड्यूस्ड हो रहा है और यहाँ से प्रोड्यूस्ड हो रहा है. अब दोनों मिल गए तो दोनों ने मिलके क्या करा, it increase the strength of the magnetic field produced by it. So we can find the strength, we can increase the strength of the magnetic field by make this wire straight wire in the form of a loop. So by making this loop, we find that the strength of the magnetic field produced by it is increases. We can also find the direction of these magnetic field, like in the last activity we find the direction of magnetic field by using this wire and by using the cardboard. Same activity we can perform for this loop. Suppose this is a cardboard and make two holes here and pass the loop through this cardboard and connect it with the battery or the cell and with the switch. And if we switch on, the current will start passing through this circuit. And by sprinkle the iron filings, and we know that if we tap it, the iron filings will arrange themselves in this direction like this. And at the center we find that the magnetic field produced by it is like a straight line. What are the factors on which the strength of the magnetic field at the center depends on? You can write the magnetic field, the magnitude of magnetic field, the magnitude of magnetic field produced by current carrying circular loop at the center depends on which factors the strength of the magnetic field, yeah, the magnitude of the magnetic field produced this loop depends. First of all, it depends on the current. By increasing the current in this loop, we can increase the strength of the magnetic field produced by it at the center. At the center, we know that all the magnetic field produced by these two parts of the wire adds up. यहाँ से जो मैग्नीट्यूड प्रोड्यूस्ड हुआ और यहाँ से जो प्रोड्यूस्ड हुआ, दोनों आपस में मिल गए तो इस जगह की स्ट्रेंथ बहुत ज़्यादा बढ़ जाती है. तो फर्स्ट ऑफ ऑल इट डिपेंड्स ऑन द करंट पासिंग थ्रू इट. बाय इंक्रीजिंग द करंट, इट इज़ डायरेक्ट प्रोपोर्शनल टू द करंट. इट मीन्स बाय इंक्रीजिंग द करंट वी कैन इंक्रीज द स्ट्रेंथ ऑफ द मैग्नेटिक फील्ड. And the second factor on which it depends, it is inversely proportional. The magnitude is inversely proportional to the radius of this coil. If we make a large loop of this wire, by making the large loop, we will decrease the strength at the center of the magnetic field. अब जितना बड़ा इस कॉइल को कर देंगे, स्ट्रेंथ उतनी कम हो जाएगी. आप इसको समझ भी सकते हैं कि स्ट्रेंथ इससे बन रही है. और आपने ये भी पढ़ा था कि द डिस्टेंस इज इनवर्सली प्रोपोर्शनल टू द स्ट्रेंथ ऑफ द मैग्नेटिक फील्ड. बाय इंक्रीजिंग द डिस्टेंस ऑफ द पॉइंट वी विल डिक्रीज द मैग्नीट्यूड ऑफ द मैग्नेटिक फील्ड. तो आप जितना बड़ा इसको कर देंगे, सोचिए इसके लिए स्ट्रेंथ यहाँ पे कम होगी, इसकी भी स्ट्रेंथ यहाँ पे कम होगी, तो इसलिए सेंटर पे स्ट्रेंथ क्या होती है, कम हो जाती है. तो मैग्नीट्यूड डायरेक्टली प्रोपोर्शनल टू द करंट. By increasing the current, we can increase the strength of the magnetic field produced by it, and by decreasing the radius, we can increase the strength of the magnetic field produced by it. Now, if we want to increase much more strength of this magnetic field produced by this coil, we can make the n number of turns by it. By making the number of turns, by increasing the number of turns, this is a one loop, and we can make more loops like this. So we use a number of turns. अभी एक टर्न से स्ट्रेंथ हुआ था और आपने टर्न्स बहुत सारे बढ़ा दिए. अब क्या होगा, what will happen? we know that this wire is behave like a magnet. Now this point of this wire is behave like a magnet. This point is also behave like a magnet. This point is also behave like a magnet. And we know that the direction of the magnetic field produced by these wires is in the same direction. By using the thumb rule, we can find the direction of the magnetic field. Suppose the direction of magnetic field is in this direction. Magnitude of the direction of magnetic field produced will be in this direction. तो सबका डायरेक्शन यही है. डायरेक्शन ये रहा. अब क्या है, आपने नंबर ऑफ टर्न्स इंक्रीज कर दिया. तो जब आप नंबर ऑफ टर्न्स बढ़ा देते हैं तो ये जितने भी सबके पास कंसंट्रिक सर्कल्स बन रहे हैं, इट मीन्स सब ने अपना अपना मैग्नेटिक फील्ड बना दिया. अब सब मैग्नेटिक फील्ड आपस में क्या हो जाएंगे, दे एड्स अप, आपस में सब मिल जाएंगे और दे विल इंक्रीज द स्ट्रेंथ ऑफ द मैग्नेटिक फील्ड प्रोड्यूस्ड बाय इट. सो सबके अपने अपने कॉइल से इन सबको मिला दिया जाता है, तो कुछ इस तरह से जो है वो मैग्नेटिक फील्ड प्रोड्यूस्ड होता है. आई एम यूजिंग द नेक्स्ट पेज for explaining this one. This is actually, we call it solenoid. What is a solenoid? Solenoid is making by using a insulated copper wire and make it a number of turns. We can use a cardboard here. Suppose we use a cardboard, we make a roll of this cardboard. I'm using here a paper. Suppose this is a cardboard and make it like this. Make it like a cylindrical, is formed in the cylindrical shape. Now what will we do? We make a loop around it. You use a insulated copper wire. Insulated copper wire means copper wire जिनके ऊपर insulation हो, उनके ऊपर covering हो, plastic covering हो. तो we use a insulated copper wire and turn around it. And by making this turn and by connecting it with the switch and the battery, we will make a solenoid. So this is called a solenoid. So this is a solenoid, और By using a cardboard you can make it, and pass the current through this solenoid. Since all the parts, all the loops of this solenoid behave like a magnet and they produce their own magnetic field, by adding all these magnetic field produced by all this loop, we can find that the strength of the magnetic field increases. And what is the type of magnetic field produced around this wire? This is like within the coil, within the solenoid is in the straight, it is like in the uniformly सब एक जैसे होते हैं अंदर, और outside the loop, outside this solenoid is in this shape. This is the magnetic field produced by this solenoid. Okay, now if we want to increase the strength of this solenoid, what we'll have to do? First of all, we should connect it with the battery and a switch. If we want to increase the strength of this solenoid, what should we do? First, by increasing the current passing through it, you can write here a heading, how can we increase the strength of the magnetic field produced by a solenoid? First of all, we know that the strength is directly proportional to the current. So by increasing the current, we can increase the strength of the magnetic field produced by it. Second one, by increasing the number of turns. By increasing the number of turns, we can increase the strength of the magnetic field produced by it. I explained you how the strength of the magnetic field produced by this solenoid increases. Okay, and the third factor, we know that by making the coil with the larger in a larger shape, means बड़ा सर्कल आपने बनाया, एक छोटा सर्कल आपने बनाया, तो the strength of this small circle will be larger as compared to this one. So by decreasing the radius of this solenoid, so on three factors, this magnitude of the magnetic field produced by the solenoid depends. Okay, now the next one, the magnetic field produced on the depends on the solenoid. Okay, I don't write the heading here. You can write the heading magnetic field due to the current in a solenoid. This is a solenoid. We can write it solenoid. You can please write there, write here a heading, that is magnetic field due to the current in a solenoid. Now if you want to increase the strength of the solenoid, we can use another thing, that is we can use a core material. What is this core material? Core material like the soft iron core. Suppose this is a cardboard and we make a solenoid here by using this cardboard. Now place a soft iron core in this, within this solenoid. What will happen? We know that by passing the current in this coil, we know the magnetic field produced by it. And what is the property of this iron? Iron has a property that is magnetized when it come in the contact with another magnet. So what will happen? This iron core is behave like a magnet. This iron core is just like behave like a magnet. So what will happen? The strength of this solenoid will increases because it has its own magnetic field, its own magnitude of magnetic field, its own strength. And what will happen if we use a core magnet? Core magnet will also magnetized. अब इसका तो अपना मैग्नेटिज्म था ही, साथ में कोर का भी इसको मैग्नेटिज्म मिल गया. तो जब इसको आयरन कोर को हमने यूज़ करा इसके अंदर, तो वी इंक्रीज द मैग्नीट्यूड ऑफ magnetic field produced around it. So we can increase the magnitude by using a iron as a core material. If we use iron as a core material, this iron is also behave like a magnet, so the strength of this solenoid increases. And this type of combination in which we use the iron core as a core material within the solenoid, this is called electromagnet. Electromagnet. This is an electromagnet. We can use iron here as a core material, not other material like some alloy like the steel. We know that the property of this iron is this: when it come in the contact with the magnetic material, it also magnetized. और if we switch off this circuit, आपने इसमें करंट बंद कर दिया, तो अब ये जो वायर था, it's not behave like a magnet now, and this iron is also stop behaving like a magnet. This is the main property of this iron. And what will happen if we use a steel other than this iron? If we use this steel become permanent magnet. It means if we switch off the current in this wire, we find that this steel do not lose its property of magnetism. It again behave like a magnet. It becomes a permanent magnet. So we don't use steel or other alloy as a core material for making the electromagnet. We actually use iron as a core material. I told you why we use iron as a core material. So you can write here a question: why we use iron as a core material? Why we should use iron as a core material, not the steel? You can write the answer. Okay. Now we know that if it is a magnet, it behave like a magnet. First of all, we are talking about this solenoid. If it is a magnet, then it should have two poles. Like a bar magnet has two poles. So every magnet has two poles. So if this solenoid behave as a magnet, it should have poles like the north pole and the south pole. If we hang it with a thread like a bar magnet, a bar magnet with a thread, we find it is always aligned in the direction of north and south. The pole which is directed towards the north, we call it the north pole, and the pole which is directed towards the south, we call it the south pole. What will happen if we hang it this solenoid by a thread? We find it also aligned in the direction of north and south. It means it also behave like a magnet, just like a bar magnet. How can we find the direction of poles of this solenoid? We can use a bar magnet. If we bring a north pole towards this solenoid, and if they repel each other, then we will find that this will be the north pole. Or if we bring a south pole here and it repel the south pole, it means this is the south pole. Since we know that opposite poles attract each other and same poles repel each other. So by using this bar magnet, we can find the direction of we can find the pole of this solenoid. We can also find the poles of this solenoid, but by hanging it freely, we will find that which part is pointed towards the north direction is a north pole, and which pointed towards the south direction is a south pole. Other than this, we have another rule by which we can find the north and a south pole of this solenoid. It means if we look at this coil, if we look at from this point, suppose this is the coil and I'm making the coil here, and this is the direction of current in this coil. This is the direction of current in the coil. अब सोचो आप इधर से इसको देख रहे हो, आप एक तरफ से इसको देख रहे हो. I am using this cardboard. सपोज आपने जो है इसमें कॉइल आपने ऐसे करके लपेटी हुई है और आप इधर से देख रहे हैं, तो आप एक तरफ से देखोगे तो सपोज डायरेक्शन ऑफ करंट आपका ये है. इट मीन्स डायरेक्शन ऑफ करंट मैंने ये दिखा दिया कि ये जो कॉइल को जब मैं इस तरफ से देखती हूँ तो मेरा डायरेक्शन ऑफ करंट ये आता है. तो अगर डायरेक्शन ऑफ करंट ये आता है तो उसको आप कहते हैं दिस इज़ अ साउथ पोल. इट मीन्स अगर डायरेक्शन ऑफ करंट इन द कॉइल इज इन clockwise direction, it will be a south pole. If this same solenoid we look at from here, कि अगर ये solenoid था, इसमें डायरेक्शन आप इस तरफ दिखा रहे हो, तो अपोजिट किस तरफ दिखेगा? उल्टा दिखेगा, इसका जस्ट अपोजिट. तो अगर आप इसको इस साइड से देखते हैं तो यू फाइंड दैट द डायरेक्शन ऑफ करंट इज इन दिस डायरेक्शन, जस्ट अपोजिट टू दिस वन. And this will be the north pole. It means if the direction of current is in anti-clockwise, it will be a north pole. Okay, then we can find the direction, we can find the poles of this solenoid by using a bar magnet, or by using this one, that if the direction of current is clockwise direction, it will be a south pole, or if it is in the anti-clockwise direction, it will be a north pole. Okay, now what is the difference between this electromagnet we prepare here? This is the electromagnet, and this is a permanent magnet. We actually use the bar magnet. So what is the difference between this electromagnet and this bar magnet? How this electromagnet is more better than this bar magnet? We make electromagnet, I explained to you, by making a coil, by making a loop around a iron core, or we placed the iron core within the solenoid, we can prepare a electromagnet. What is the difference between this electromagnet and this bar magnet? They behave like a magnet. Both of them are behave like a magnet. They both have the north and a south pole. Both have the same type of magnetic field around it. So what is the difference between them? We can write the difference between the electromagnet and the permanent magnet. Here I am writing the permanent magnet. Permanent magnet. And this is the electromagnet. First, permanent magnet is a permanent magnet. It means if we want, हम चाहें कि ये magnet ना रहे, तो it is not possible. Permanent magnet is a permanent magnet. Is permanently it is magnet. But electromagnet is a temporary magnet. Temporary magnet, it is a permanent magnet. We can't lose its magnetic properties. It can't lose its magnetic properties. It is permanent. Second one, it produces weak force of attraction. This permanent magnet produces weak force of attraction. And this electromagnet, it produces very strong force of attraction. Produces a very strong force of attraction. Okay. Third point, its strength, we can't change the strength of this magnet. It has its own strength. It can be weak, it can be strong, but it has its own strength. We can't change. We cannot change its strength. But what about the electromagnet? We can change its strength by changing, we can increase the strength of this magnetic field, like by increasing the number of turns, by increasing the current through it, and by using the core material like the iron core. So we can increase the strength of this magnetic field, electromagnet. So we can increase, third point, we can change the strength of magnetic field. So we can change the strength of this magnetic field, but can't for this one. And fourth one, we cannot change the poles of this magnet. North pole will always be north pole and south pole will always be south pole. So we cannot change the poles of permanent magnet. But what about this electromagnet? By changing the direction of current. First, we connect it with the positive terminal, the direction of current is this one. And secondly, we change the direction of magnetic field by changing the poles of this battery. We find that the poles of the electromagnet also conversed, change हो जाते हैं. So we can change the poles of electromagnet. So it means electromagnet is more better than permanent magnet in many aspects. Okay, today we'll study the magnetic field due to the current through the circular loop, through the solenoid, and about the electromagnet. And we also studied the electromagnet is better than the permanent magnet and why it is better than the permanent magnet. Okay, bye.